Right, we left off on the laws of logic, so that's where we'll pick up. So I went through the laws of double negation in the last video. Two negation signs and a primitive pretty much is logically equivalent to just P. Now we have 9 more laws to remember. The second one is the Morgan's law, which I made a video about in one of my past videos, so I'm pretty sure you would remember it. You're just taking the negated symbol and you're expanding it with the statement, and you get the following statement. So that's pretty simple. Commutative laws is also pretty simple. All you're doing, well, the the logical connectives ands, ors, they all stay the same. So you can see here that this is an or, and that is also an or. What is actually happening is you're just flipping these two symbols Q and P around. So you're just trading places. So that's a commutative law. It's pretty simple. And associative laws, it's kind of like the distributive laws, but not exactly. So what happened is that you're just moving these brackets because you see here that the brackets currently surround Q and R, and that is logically equivalent to when the brackets surround P or Q. All these symbols stay the same for the associative laws. You can see here that these are all ors and these are all ands. These are all ors and these are all ands. Yeah, the symbols stay the same. It's just that the bracket is what moves. But yeah, so the distributive laws is what we went through in the last video, and I'm pretty sure I explained it pretty well. But to expand it further, it's just like where is that? Yeah, it's just like the A times B plus C. You're just expanding A times to B plus C, and you get this expanded formula, this expanded statement, and that's pretty much the distributive laws for you. Idempotent and identity laws and the next two laws are pretty damn simple. I mean, if you don't get it, then you're kind of retarded because, well, let's see. For idempotent laws, you're pretty much saying and or P is by is logical equivalent to P, or by and P is logical equivalent to P. Identity laws, P or FO is logical equivalent to P. P and TO is logical equivalent to P. Simple, right? Man, I don't know which one's going forward and which one's going backward. This is horrible. This is bad UI design, just as a side note. I don't know which one goes forward and which one goes backwards. So inverse law is pretty much the same. God damn it. Inverse laws is pretty much the same as the identity laws. And domination laws is kind of like the inverse laws. And the absorption laws, yeah, it's just what you see here. P or P and Q is logic equivalent to P, yada yada yada. So what I'm getting at is the tricky laws that you got to remember, or the ones that you probably might mess with the most, is the commutative laws, the associative laws, and the distributive laws. And these idempotent identity laws and what are the other three? Inverse laws, domination laws, absorption laws. Just keep them at the back of your head because they're really similar, but the the risk here is that you might get them mixed up, and you do not want to get these laws mixed up because they're different. So yeah, that's all about the laws, and I cannot stress how important they are. You gotta remember them. I don't know, make a cheat sheet if you must, and take that cheat sheet to your test if you're not allowed. If you get caught cheating, then you did not learn that from me, and you should beg for forgiveness. But sarcasm aside, you should really, really memorize all these laws. Now, the definition that we're gonna go through next is the dual of S. Now, this is not exactly related to the laws of logic, but well, you'll see. So, this is the definition. Let S be a statement if S has no logical connectives other than and or, then we call it the dual of S, and that's denoted as SD, which is obtained from S by replacing each occurrence of and or by or and respectively, tautologies and contradictions by contradictions, and tautologies, respectively. And yeah, I'm gonna stop calling these tautologies and contradictions. I'm gonna start calling them true and false because it's more simple to me instead of using all these formal languages. But they're really called tautologies and contradictions. But I'm just gonna call them true and false from now on because that's more intuitive for me. Might be more intuitive for you too. So here's the example that I want to go through. So pretty much the dual of P, that is pretty much equal to P. And the negated dual of P, or negated P, or the dual of negated P is the same as saying negated P. So uh, when you have a statement or a variable like P, the dual of P is pretty much just P. For negated P, the dual of negated P is just negated P. The things that you gotta worry about here are the symbols. So whenever P is primitive, then P or negated P is equal to what? Well, in this case, all you have to worry about is the symbols. P or negated P, well, the dual of that is P and negated P. So let's say that this the statement is P or negated P, while P and negated P is the dual of S. Similarly, for P or tautology or true, then in that case, you just say P and false. And that would be our SD if this was our S. Because remember, what you're doing is you're just replacing each occurrence of and or by or and. So if you have an and, then you replace it by an or. If you have an or, then you replace it by an and. If you have a true, you replace it by a false. If you have a false, you replace it by a true. It's as simple as that. So given the primitive statements PQR and the compound statement S, which is this, I want you guys to pause the video and find SD. So I'm just going to go right through it because I've already did it. So in this case, all we're doing is, remember, we're just switching the symbols. The variables, they don't change. So what's happening is we're going to change all the logical connectives and anything that's true or false. So in this case, our dual of S is, well, that's an and, so we're getting an or here. That's an or, so we're getting an and here. That's an and, so we're getting an or, and that's true, so we're replacing it with a false. So if that's what you got, then you're correct, and you got this in the back in your hand. You don't gotta worry about it because you're gonna do great on whatever your professor throws at you concerning duals. And that's all I want to teach you in this video. Pretty simple. Remember to memorize those laws of logic because if you don't memorize them, then you're pretty much screwed because they're so damn important. Other than that, please rate, comment, subscribe, and I'll see you guys.